the application you just saw.
Thank you, Mark. I'm going to go through the environment that the application is actually deployed in. I'm going to talk a little bit about the technology stack, and then I'm going to talk about the very high level, the application architecture. And then I'm going to hand over to Keith and Kunal to talk about more of the details about our implementation and the technical patterns that we ended up leveraging or we wanted to call out for your guys' benefit. The application architecture. This is the environment that our applications run in. The application that you just saw is deployed to a server that is in the store itself. The application interacts with a MySQL database, again, on the store server in the back room of a store. We deploy our applications to the store, not to a central office, because we have limited bandwidth between the store and the central office. And we also want to be able to use the applications in the case of offline or when the network back to the central office is not available. The application that we saw, and we'll talk a little bit more about this, is leveraged from 3 different devices at the store. One of which is a PC very similar to the demo that you're seeing right here in the back office that the manager would use using a mouse. Another environment that the application is used from is the register itself. We have a PC-based register, and it's actually a Java-based application with an embedded version of IE running on the point of sale itself. And the register is a touch screen, so we've tried to make the application usable from a touch screen as well. Then the last device that we have in the store is a handheld device. We have a wireless network in the store and a handheld device which has a simple scanner that the application can be used. And again, it's the thing web application just presented in a different view that runs on the handheld device. On the device itself, we have a .NET web component that's wrapped, which enables us to interact with the scanner and also do a few other little tricks that I think Kunal will talk about. The application interacts with the central office in an asynchronous manner. The documents that Mark was referring to, the inventory documents, basically get posted in the background. So the application will actually save the documents to the MySQL database. Then it will get transmitted by a separate process that will synchronize that. We call it application level data synchronization to the central office. The central office database is a database that supports the entire chain of stores. Eventually it'll be 1,400 stores. And the synchronization that we actually accomplish is done by a piece of software called Symmetric DS. It's an open source piece of software that Big Lots itself developed and contributed out to the community. It's fairly we developed over the past year. It supports heterogeneous data synchronization. So in this case, it's MySQL to an Oracle rack. We've also built in support for a few other databases as well, including some of the well-known Java embedded databases, Derby and HSQLDB, then SQL Server and Postgres is what we currently support. The technology, Big Lots is very committed to open source technology. We believe that open source technology enables us to deliver applications like the one you just saw and that we'll continue to talk about. Open source by itself won't allow us to deliver the application, so it's a combination of open source technology and very good developers and good technical leadership. And so that's what we invest in. We invest in open source technology and good people as well. JBoss is our application server of choice. It's open source, and I'm guessing that I don't have to talk too much about that because you guys are all here. So, the technology stack itself is Big Lots started investing in JSF probably about 2 years ago. We quickly found out that the JSF lifecycle and the EJB, JPA hibernate lifecycle don't jive well together without something in between. And so we quickly, in order to make development easier on ourselves and not have to write a bunch of intermediary code, we investigated and started to embrace Scene. So our stack today is EJB3, JSF, facelets for the view. I don't know. Again, we're assuming some familiarity with JSF, and anybody who's worked with JSF probably tends to lean towards the technology towards like facelets versus JSP, which just has some general kind of incompatibilities with JSF. And then for component technology, or in order to get our Web 2.0 components, we've embraced Ajax for JSF and RichFaces, as well as some custom components that we've developed for this application in particular. The application architecture, we try to keep it very simple. All our applications at Big Lots, not only this inventory suite, are based on this general pattern. Very simple. I'm sure if you go to some of the scene presentations, they'll talk about how you can basically wire your facelet, your view, directly into EJBs on the back, or section beams or EJBs in the back end. We wanted to give it a little bit of structure. So we have the pattern that we came up with is called face. And we use facelets for the view, as I mentioned. We have a layer that basically acts as the controller or action handlers for the application, and we call that the action layer. In our case, they're implemented with just plain old Java beans. And the service layer, we try to isolate or abstract the business services. So while the action is very application-oriented, the action layer is very application-oriented, the service layer is very domain-oriented. And it's meant to, even though maybe some of the services that we build are going to be specific to our application, we try to build it in a way that makes sense and is reusable should we put a different view on top of it. Then we have our entities, which are the JPA domain objects, which are used across all the layers. With that, I'm going to turn it over to Kunal Bajaj for the first set of patterns.
What I'm going to talk about essentially is technical patterns that we faced throughout our project. Most of the patterns are actually phrased as questions, and the answers effectively address challenges and obstacles that we faced during the life cycle. What I'm going to talk about essentially is our patterns for infrastructure and devices, and Keith's going to talk about patterns around usability and user technology maturity. How do we make authorization rules simple, even a manager can do it? Is that right, Mark? Security is generally an afterthought in most web development efforts, right? We decided to tackle that first. We decided to use JAS because we didn't find that container-managed security was the right choice for us. JBoss's extensions to the expression language syntax definitely helped us quite a great deal. Just by using expression language syntax and using has role and has permission, probably covered about 95% of all of our needs. We made heavy use of EL to basically enforce EL role and permission checks. Essentially, the rules are expressed in one language, whether it's in views, for example, facelets, components, for example, scene managed components, and configuration files. The other thing we did, just from a consistency standpoint, is that we organized all of our content into two high-level realms. We call it effectively protected and unprotected. We then further subdivided within those realms by domain. In our case, domains effectively is like a one-to-one relation between a domain and a specific inventory application. So it became very simple for us to effectively take some very simple rules and apply them globally through Pages XML. How do we consistently implement conversations? Out of all the things that SEAM introduced, conversation probably proved to be the most challenging for us. In the end, what we decided to do was basically implement it such that all of our edit screens, anytime that we are committing changes to the database, we would actually end up beginning our conversation and ending it just when we were about to persist it. The other thing that threw us off in the very beginning was the flush mode. If you've used SEAM, you know that by default it's actually set to auto. Figuring out that manual was the one we definitely wanted to do took us a bit, but we figured it out. The other thing that was a bit of a change was all of our action components that Chris referred to in the face pattern were originally implemented as stateful session beans. However, because of the way we had document locking and some other cleanup work that needed to be done when a conversation was about to end, we found that the destroy method was not being consistently called, so we actually switched it over to being POJOs instead, and that worked out a lot better. The only caveat that we ran into was that during the destroy method, any injected dependencies of like either EJBs or other CMesh components need to be reinitialized before you can actually call them. So just a couple of things to be wary of. One is the life cycle of any injected components into your CMesh beans, and then dealing with conversation timeouts or synchronous requests. The item filter that Mark showed you earlier in the transfer out application, the search was actually originally triggered based on an on-key up event. So when we actually ended up going into UAT phase, we saw that our users were actually typing in 9-digit SKUs, with the result that even with setting up request delays and timeouts, they were sending 9 requests for every single search item. Well, eventually the flooding that was caused by this overwhelmed our app, and effectively we ended up with these warning messages that conversation timed out, and they'd end up losing data over and over again. So we basically came up with 2 different strategies to solve that. One was, one actually Keith's going to talk about in the usability section, but the other thing that we did was we actually built a ton of JSF components ourselves, and a lot of that was based on Yahoo UI's toolkit. So we basically just fronted those components as JSF components and kind of used it within our architecture. One of those components was a key listener. So all of our item filters now actually bind the enter key to a specific text field. So our users actually end up typing whatever they want and actually hit the enter key to initiate the search. That immediately cut down on the number of request cycles that the server was ending up having to do. How do we support a touchscreen monitor? If you've done any kind of development, any kind of web development that required displaying your actual application on touchscreen, there are some unique challenges that you have to deal with. One is that the finger is not the most efficient pointing device. And we didn't want to actually have to sit and write a whole new set of views just because the app was going to be accessed by essentially 3 different types of devices. In the case of a handheld, you don't really have a choice. I mean, the screens are much smaller, there's limited bandwidth, there's limited processing power and memory. But in the case of a touchscreen, we don't want to have to go about designing a whole bunch of different screens. So how did we account for the scenario that we actually had to develop our app on the touchscreen? One was that we increased the click area of our links. A lot of our screens actually have data grids. We actually wrote a custom JSF component that actually integrates data grid as well as a data page directly into one component. And what that does is we also have extensions that we've written in JavaScript. We actually associate event listeners to not just a link in a cell, but the entire cell. If there's only one action associated with a row, with a cell, the entire row essentially inherits that action as well. So basically, we make the whole cell or the entire row clickable as the situation here is. The other thing that we did was we increased our font sizes, and we made sure that there was enough negative space around components just so that the user could trigger the action that they actually meant to rather than triggering off a whole bunch. The other thing that we did was we tried to minimize page scrolling. Instead, we used fixed height components like a modal panel or a data table with fixed heights. The other thing that we did was most of our stores actually have close to almost 300,000 items that they could potentially search through. So the other thing that we invested a lot of time on is actually implementing paging, that I'm going to talk about in just a bit. This is actually a picture of a handheld scanner that Chris was referring to in the high-level architecture diagram. It's a handheld device with limited resources and no keyboard or mouse. We made the decision to choose a web app rather than a thick client application um, we actually attempted to access a full-fledged application, full-fledged view on a Pocket Internet Explorer browser. It did load. It took a while, but it did load. Now, we decided to go with the web app primarily for three reasons. One is we could have used the same skill set, the same architecture, and the same deployment strategy. So this was the first attempt that we had made at doing a web app for a handheld device, and it worked extremely well. Just a couple of things, caveats that we faced that I thought I should mention. One is the Pocket browser tends to have a ton of problems with JavaScript. So the amount of JavaScript that you actually load as part of your screens, you got to watch essentially what you're putting in. So we maximize the use of JSF components. We did not use any AJAX for JSF components on our handheld screens where possible. We limited the page size and the number of components that we have on a screen. It's a very, very simplified flow, where it's enough to actually get the task completed that the user needs. Another thing that we did was we extended a .NET web browser component and essentially helped us get rid of that last row over there. Now it might seem that we went a little bit overboard, but that little bit of gap at the bottom actually helped us place a lot of our buttons. The other thing we did was, in order to cut down on page and HTML size, we just redesigned a lot of our screen flows. And the other thing that we did was we eliminated double clicks. So because we did a custom .NET web browser component, somebody double click on a link, doesn't trigger the action twice. It makes an audible beep, so the user knows that hey, they triggered it again. The other thing that we do is because this device wasn't really custom designed for a web app, we actually have to manually activate and deactivate barcode scanner when the focus is on a text field. So that's another thing that we have to do. This is the pattern that I was actually referring to. We actually pushed all of our paging on the server side. We created a very simple pattern that we use consistently, and it works extremely well. So all of our sorting and paging is done on the service layer. We extended the list interface and basically provided accesses to the start index, the page size, and the total record count. Those three values effectively allowed us to move the cursor on the server side for every request. We also did a custom data table, data pager implementation, like I mentioned. That's an example of one right there. What I'm going to do next is actually I'm going to give you a demo of an application called Item Inquiry. Item Inquiry is an application that's used by a store associate if they are trying to find the SKU of an item. They know the description, for example, it's a towel, but they don't know what the SKU is, or they're trying to find out, how many of a particular item do we have in stock at the store. So since there were a lot of hands when people mentioned Big Lots, give me an example of an item that you might find at a Big Lots store. Go ahead.
Water pistols.
Sorry, what was that?
Water pistols.
Water pistols.